Curious Cosmos presents How Time Works in Space. Is time the same everywhere? Let's dive in. On Earth, time is simple. It ticks steadily at the same pace for everyone. But what if I told you that time works differently in space? In space, especially near massive objects like Earth or black holes, time slows down. This effect is called time dilation. Astronauts aboard the International Space Station experience time at a slightly slower rate than we do on Earth. It's because they're moving so fast and are farther from Earth's gravitational pull. But time dilation gets much crazier when we approach a black hole. The stronger the gravity, the slower time moves. If you were to get too close to a black hole, time would appear to slow down to almost a stop for you. While to an outside observer it would seem like you're frozen in time. This phenomenon has been tested too. Astronauts who spend long periods in space age slightly less than those of us on Earth. Time isn't the same everywhere in space. It stretches and compresses depending on gravity and motion. Isn't that mind-blowing? Like, share, and subscribe to explore more mind-bending cosmic facts. Time is one of the most fascinating concepts in the universe. We often take it for granted, but it's a fundamental part of our existence. From the ancient sundials to modern atomic clocks, humans have always been obsessed with measuring time. But what exactly is time? Time is a measure of change. It's the progression of events from the past to the present and into the future. On Earth, we experience time in a linear fashion. Seconds turn into minutes, minutes into hours, and hours into days. But in the vast expanse of space, time behaves differently. The concept of time dilation was first introduced by Albert Einstein in his theory of relativity. According to Einstein, time is not a constant. It can be stretched or compressed depending on the speed and gravity. This means that time can flow at different rates in different parts of the universe. For example, time moves slower near massive objects like planets and stars. This is because the gravitational pull of these objects warps the fabric of space-time. The stronger the gravity, the more time slows down. Black holes are the most extreme example of this phenomenon. Their gravity is so strong that it can slow down time to almost a standstill. If you were to travel close to a black hole, time would slow down for you compared to someone far away. This means that you could experience minutes, while years pass for someone else. This has fascinating implications for space travel. Astronauts traveling at high speeds or near massive objects could age more slowly than people on Earth. This means that time travel, at least to the future, is theoretically possible. But it's not just massive objects that affect time. Speed also plays a crucial role. The faster you move, the slower time passes for you. This is why astronauts on the International Space Station, who are traveling at high speeds, experience time slightly slower than people on Earth. This effect is tiny but measurable. Over long periods it can add up, meaning that astronauts age slightly less than people on Earth. This is a real-world example of time dilation in action. So, the next time you look at a clock, remember that time is not as constant as it seems. It's a flexible and dynamic part of our universe influenced by speed and gravity. And as we continue to explore the cosmos, we'll keep uncovering more about the mysteries of time. Isn't that mind-blowing? Like, share and subscribe to explore more mind-bending cosmic facts?